Hello, everybody. Welcome to an episode of Analytics Mindset. In this case, we're going to look into standardization and normalization in Python. This will be a more conceptual session than most of them, actually, and we will be looking more into why we do things in programming. And I will not go that much into syntax, but this goes a lot through sklearn. If you are not used to sklearn or need some refresh on some of its concepts or its syntax, because syntax can be very, very different than base Python. I'm leaving the documentation for all of these in the description below as well. With that being said, the only prerequisite for this is understanding some programming basics. If you do, we're good to go. If not, please look at my basic programming video. There's going to be somewhere over here. Let's start by getting our usual libraries. I'm gonna get pandas, matplotlib pyplot as PLT, and this is new, sklearn preprocessing. This is another library that we're gonna use. I'm more focused on how to do preprocessing here. And as you can see here, we have a lot of different methods to preprocess data, including scaling, centering, normalization, and binarization that we will not go into today, but we're going to focus on the first three to some degree, and NumPy, because we need NumPy. From there, I'm going to create a data frame. We're going to say this can be anything you want. Let's call it hotel data. We can say we have this many hotels and they have this many bookings. That's a very easy way to say. We're going to explore this data frame really quickly. As you can see, Spider gives us the variable explorer. We can see how the record 4,892, is way bigger than all the other records. That's a problem. If we were to predict a new observation for this, for example, we may find that it is just not possible for us to do that because there is too much of a magnitude of difference between all of these values. It's true that a lot of algorithms don't care, but it is always a good practice to have the same magnitude in your data if possible, or at least two magnitudes in your data. More than that, 3 to 4, 5 between the minimum and the maximum, you should really consider if we need to get standardization or normalization to be able to see it better. And this plot here from matplotlib is going to show us a little bit more about that. You can see here, all of them are pretty much nothing compared to 4, and 4 has by far most of the weight if we were talking about the distribution here, most of the mass, if it was continuous. It is not, but if you were talking more in statistical terms, that would be most of the total value here is here. Now, there is that big old layer there. We could exclude it, or we can normalize the data to preprocess this data. And in this case, we're going to do that. Now, sklearn has a normalize function. We're going to start with that. Normalized from preprocessing allows us to take this data frame and then the values only. So I'm going to show you how this looks like here. This is what sklearn wants. It wants an array of the values. And then norm max. What does norm max mean, actually? Normalize is a function with a lot of underlying assumptions inside of it. You can say there, norm is used to normalize each non-zero sample. So we're going to do that. And then we're going to look at normalized data. You can see here, I got an array, and this array is way different than my data frame. However, if I put them side by side, and you can see that the shape is pretty different too. But if I can align them close enough, you could see how number 4 has a value of 1. Why? Because it's the maximum. Then you have 0, there is 3 here, it's almost nothing here. You have the 6 value, 1.5, it's almost nothing here. It is correct in a sense that most of the deviation that was found of the maximum to minimum value, the closer to the minimum value is going to be the closer to 0. The closest to the maximum value, in this case 4,892, the closest to 1, and in the case of the same number, it's going to be. That's normalization. You are constricting. There is a lot of different kinds of normalization. The one that we're using here is min-max normalization that takes whichever the scale you have, whichever range, and compresses it between 0 and 1, where 0 is your minimum value and 1 is your maximum value. That way, you are still having your same data, but you have compressed it in that range. But that's a little bit of a very, very high level overview of normalization, and honestly, is very black box. So we can do it ourselves. We're just gonna go into the actual math behind it. You can see here, manual normalized data. I'm going to take my data from my data frame. So slicing the data frame here, and we can just execute this so you can see what's inside here. These are my data. Then I'm gonna take the minimum values. This is important. It's 1.5, so all of these are gonna be subtracted 1.5. And actually, if we just take this before the division, you can see how we subtract 1.5 from everything here. Then we take the maximum value. And then we subtract the minimum value there. We get this value here. So we're gonna divide each single one of these ones over this. And that gives us our result. We just execute everything once we divide it. And this is our result here. That is the manual normalized data that we're gonna execute now. Now, you may notice that it is not exactly the same as this one. Why? Because the normalized parameter in sklearn, the normalized function, is a little bit different and has different assumptions underlying it, but it's close enough. You can see how it has most of that, the closest to 1 is going to be the maximum value. In this case, we already saw it, the fourth one. They agree on that. The rest of them are very, very similar, barely any difference between the scales, pretty much. However, we can have the same scale in sklearn with the min-max scalar. So we're going to take the min-max scalar, and then we are going to use fit transform to take the data. It needs to be reshaped because sklearn usually uses that when it's in one dimension. And now you can look at here min-max normalized data, and we can compare these to our manual normalized data. They are exactly the same. This is how it works for normalizing. Again, there is a lot of different ways of normalizing. You have sklearn norms. You also have the 1 to -1 normalization. Usually, I just go with the easiest one, that is from 0 to 1. That allows us to have our data in a range that makes sense and preserves original data values as well. Now, normalization is one of the two biggest ways of preprocessing data for machine learning algorithms. The other one is standardization. Standardization takes the data and then you basically take the mean out of it and then divide by the standard deviation. It is, you may recall from your stats classes where you needed to bring from any distribution how it would fit into the normal curve, given this mean, this standard deviation, this is based on that. That might be a connection that you may want to do if you have had that stats background. And when we take this, we're gonna take the manual standardized data. You can see how it's gonna be expressed on how much they are above or below the standard deviation of the distribution. In this case, 4 is by far the farthest away above the standard deviation, because if we had the normal curve, then this fourth value would be all the way to the end. And you can see how the other ones are pretty much in the mean, because the mean is pretty close by, because you have so many values that are around that area there. Even if we have that little value that is all the way there, that pushes the mean to that value, the rest of the values still dictate most of the distribution there, making it going to the right. And that's why they are negative there. We could actually just take this and inspect every single part of it. We can take the mean. You can look at it how it's 582. So most of these are for sure to the left of the distribution, to the negative side. But you still have some of them to the right side of it. Well, one of them in this case. And then we can take the standard deviation. That is a lot for sure. You're dividing it by that, and that's how you're getting that. You are centering into the standard distribution and putting that into the Gaussian curve. Why this? Because by default, standard deviation in Python has the degrees of freedom 1, and that's different how sklearn does it. You can have a debate that sklearn shouldn't do it like that, but I just put it like that for our purposes to explain, and so this matches the standard scholar from sklearn. You can see how it's a little bit different because it has 1 degree of freedom because it is a sample. It's assuming it's a sample. But with that being said, we can perform it in sklearn, as I mentioned before. We're gonna take the standard scholar and we use standard scholar feed data. And then we're gonna take our data that we need to take the values and then reshape it so sklearn doesn't shout at us. And from there, we're going to call scal data standard scholar that transform our data. And we can look at the scal data here, scalar data, and look at our manual standardized data. And you'll notice they're exactly the same because they have exactly the same map besides that removal of that degree of freedom that I did manually. But they are exactly the same and have the same distribution. Now, they are good practices, even if you're not using a machine learning model, they can help you understanding better how your data looks like. You could just take this and then plot it. That will give you a nice range from 0 to 1, for example, in the case of normalization. In the case of standardization, it will give you a better understanding of how your data looks like comparing to the standard distribution, the uniform distribution. Finally, it's worth mentioning too that these methods are provided too in some algorithms, especially in sklearn. You may have the option to just do it straightforward. You may want to do it like, do you want me to center it? And the algorithm says, yeah, I will center it. It's always good to just notice and use, if possible. You may want to pre-process your data. Do you want to include the outliers? For sure, some models are going to be way more unstable if you don't normalize your data beforehand. PCA, principal component analysis, is one algorithm that usually prefers standardized values, normalized or standardized, but usually standardized. And you will need to pre-process that before putting them inside the model. With that being said, I hope that this helped you learning more about standardization and normalization and their uses, and that not only is good for pre-processing data, but can also give you some insights on your data as well. Thank you. If you have any feedback, feel free to give it as always, and I hope I see you next time.